Hi there, Miss Barber here. This lesson is titled Exponential Functions. This lesson begins our comprehensive study of exponential and logarithmic functions. These functions are used to model many real-world phenomena such as a growth of a population, an investment that earns compound interest, and the rate of decay of radioactive substances. With an appropriate exponential model, we are able to make reasonable predictions of future population size, or estimate the future value of an investment, or even find the amount of radioactive substance that may remain after a certain period of time. The learning objectives for this lesson are: 1. Know the characteristics of exponential functions. 2. Be able to graph exponential functions. And 3. Be able to solve compound interest applications. Roman numeral 1. Exponential functions. The exponential function with base a is defined for all real numbers x by f of x equals a to the x, where a is positive and a does not equal 1. Let's note that with exponential functions, the base is a constant and the exponent is the variable. Provided for you here is the list of all the laws of exponents. The laws of exponents that you learn to work with real numbers also work for the exponential function. Use the laws of exponents to simplify. A, b to the power of 7 raised to the 5. In order to solve this, we would write this as b to the power of 7 times 5. And so this would simplify to b to the power of 35. Part B, x over 2 quantity raised to the 5. We would write this as x to the 5 divided by 2 to the 5. Simplified some more, you get x to the 5th, and 2 to the 5th is 32. Roman numeral 2, graphs of exponential functions. Consider the exponential function y equals 2 to the power of x. Let's get a visual of what this graph looks like. Begin with a t-chart, x in the first column, f of x or y for the second column, and we choose values for x. I'll choose -2, -1, 0, 1, 2, and 3, and we will evaluate each of these input values in the function y equals 2 to the x. For y equals 2 to the -2, recall the laws of exponents. That tells us to write that as 1 over 2 squared. Remember, the negative in the exponent reciprocates that expression, and 1 over 2 squared is 1/4. Let's evaluate at 2 to the -1. That means we're going to take the reciprocal of the 2, so it would be 1/2. Now we will look at 2 to the 0, and an exponent power of 0 tells us we're going to get 1, so you get an ordered pair, 0, 1. Let's do for 2 to the 1. That's just going to be 2. 2 squared is 4, and 2 cubed is 2 times 2 times 2, which is 8. Now let's plot these ordered pairs. I will start at 0, 1. That's easy enough. And then we'll go to 1, 2. Then 2, ordered pair 4, 3, all the way up to 8. Now let's go to the left side of the number line. At -1, the function has a 1/2 value, and at -2, it has a 1/4. If you were to carry out a sufficient number of points, you would see what looks like an exponential growth function. Let's look at some of the characteristics. Properties of exponential function graphs of the form f of x equals a to the x, provided that a is positive and a does not equal 1. First, the domain is the set of real numbers. The function evaluates at negative, at 0, and at 1, and any other number that's real. And the range is 0 to infinity. 2. The line y equals 0, which is the x-axis, is a horizontal asymptote of the function f. Next characteristic. The point 0, 1 is on the graph. 4, the point 1, a. Notice that's the base, so for y equals 2 to the x, it's 1, 2 is on the graph. And if a, the base, is between 0 and 1, then f, the exponential function, decreases rapidly. And if a, the base, is greater than 1, then f, the exponential function, increases rapidly. Find the exponential function f of x equals a to the x for the graph given. To find the exponential function means we need to find the base value a. So let's consider the form y equals a to the x, and let's look at the graph. There are many points. Let's get the one that's on the y-axis, and that would be the ordered pair, 0, 1. And another point that's right on a cross grid is -1, 4. Let's find a. I'll use the first ordered pair, putting in 1 for the y, get 1 equals a to the 0 for x, and well, a to the 0 is 1. We get 1 equals 1, which is true, and it doesn't tell us what the base a is. Let's try it with the other ordered pair. I'll put in y value, which is 4, equals a raised to the -1. That's the x value. Now we can actually solve for a. We take the power to the -1 on both sides, and we get that 4 to the -1 equals our base a. So now let's write in 4 to the -1 for the base a. We have f of x equals, and where the a was, we'll write 4 to the -1 to the x, which is 4 to the -x. And there are two correct ways in which you can express this function. It can be written as f of x equals 4 to the -x, and it is also correct to write this as f of x equals 1/4 to the power of positive x. Graph the exponential function y equals 2 to the power of quantity x minus 3 minus 1. Let's recognize that this is a transformation of the graph y equals 2 to the x. So we begin with the graph of y equals 2 to the x, and let's look at the transformations. We've got y equals 2 to the power of x minus 3 minus 1. This could be written in function notation such that we have y equals f of x minus 3 minus 1. Then we can see the setup for the transformations. The minus 3 is a shift to the right 3 units. The minus 1 is a shift down 1 unit. So let's make those transformations. I'll begin with the horizontal asymptote. For y equals 2 to the x, the horizontal asymptote is the x-axis, or y equals 0. The shift down 1 tells us we move the horizontal asymptote down 1 unit. Now let's move some key points. We have a 0, 1. Let's shift that down 1. We have another point. Let's shift that down 1. And let's do one more. Shift that point. That's 2, 4. And let's go all the way to 3, 8. So we did the shift down. Now let's shift right 3 points. So we'll go from the origin to 1, 2, 3. And then the point we had, which was 1, 1, go to the right, 3. Go to the next, go right, 3. And finally, we'll take the point that we shifted from 3, 7 to over right. So it'll be 6, 7. And then we can connect those points. Here we go. Roman numeral 3, compound interest. Compound interest is calculated by the formula A equals P times the quantity 1 plus r over n, all raised to the power of n times t, where a equals the amount after t years. This is often referred to as either future value or account balance. Capital P is equal to principal or present value. That's the value of your money at this moment today. R is equal to the interest rate per year. You often see this as APR. Your interest rate in the formula must be expressed in decimal form. N equals the number of compoundings per year. N is the number of times the money is compounded. So for example, if it is compounded quarterly, N equals 4. If it is compounded monthly, then N equals 12. T equals the number of years. So if an investment is timed at 18 months, it's very important that you convert that to 1.5 years. If an investment earns compound interest, then the annual percentage yield, that's APY, is the simple interest rate that yields the same amount at the end of a one-year cycle. Find the present value of $100,000 if interest is paid at a rate of 5.25% per year compounded monthly for 5 years. We deduce from the statement of the problem that this is a compound interest problem. So let's begin with the compound interest formula, which is A equals P times 1 plus R over N to the NT. Then let's identify the parts. Okay? It says find the present value, so what we are looking for is the P. The $100,000 is the future value, and that's the A. Now the rate is 5.25%, so in decimal form it'll be 0.0525. Time is for 5 years, and it says compounded monthly. We have 12 months in a year, so N equals 12. Now let's put the numbers in for the variables in the formula. So we will get 100,000 is equal to P times 1 plus the rate 0.0525 divided by 12 raised to the power of the product of 12 times 5. Let's continue. Then we get 100,000 is equal to P times, use your scientific calculator to compute, 1 plus 0.0525 divided by 12. Do not round during the computation. So you'll get 1.004375 raised to the power of 12 times 5 is 60. Okay. And now in your calculator, compute the 1.004375 raised to the power of 60 and write out all of the digits on your calculator screen. So you have 100,000 equals P times 1.29943266. Now you can solve for P by dividing by the 1.29943266 on both sides. And when you do, you'll get P is equal to 7,696.68533. And since we are talking about money, we'll round it to the nearest cent. And we get that the present value is, use the dollar symbol, 76,956 dot, rounding to the nearest cent, would be 69 cents. So $76,956.69. If you let it earn interest at 5.25% for 5 years, that amount will be worth $100,000.